Assalamualaikum to the respected lecturers and Najib. My name is Rabata Adawiyah binti Suhri from Group 7. Let me introduce you to other team members in Group 7, which are Sarah Hanani, Nur Emilia Atasha, and Nurul Ain. In this video, we're going to present about aluminium oxide. These are the contents of this video. Before we learn about aluminium oxide, we need to know what is aluminium. Well, aluminium is a chemical element with the symbol Al and its atomic number is 13. Second, it is the third most abundant element in Earth's crust. The first and second are oxygen and silicon respectively. Besides, it can only exist as compounds. Lastly, the chief ore of aluminium is bauxite. Slide, you can see that aluminium has electron configuration of Ne 3s2 111, acid-base properties of higher valence oxides, crystal structure, face-centered cubic, and equal relative strength. Moving on to aluminium properties that can be divided into physical and chemical properties. Physical properties are the characteristics that can be observed without changing the substance into another substance and usually can be observed using our senses. For instance, hardness. The pure aluminium is soft but it becomes strong when it is alloyed. Aluminium appears in a silver-like color with a slightly bluish tint. It can conduct electric and heat very well. It is also ductile and malleable. Ductile means capable of being pulled into thin wires, while malleable means capable of being hammered into thin sheets. Moreover, it has melting point of 660 Celsius and boiling point of 2327 to 2450 Celsius. Its density is 2.708 gram per centimeter cube. Furthermore, for the heat of fusion and heat of vaporization, it is 10.71 kJ per mole and 284 kJ per mole respectively. Lastly, aluminium has 24.20 joule of molar heat capacity. Next, I will explain about chemical properties of aluminium. So chemical properties are the characteristics that determine how it will react with other substances or change from one substance to another and only observable during a chemical reaction. Aluminium has one interesting and a very useful property, which is in moist air, it combines slowly with oxygen gas to form aluminium oxide. The aluminium oxide forms a very thin whitish coating on the aluminium metal, which prevents the metal from reacting again with oxygen gas, thus protects it from further corrosion, which is also known as rusting. These methods are widely applied in furniture and household equipment, especially cutlery. Moreover, it can react quickly with hot water, forming aluminium oxide and hydrogen gas. In addition, this metal is also fairly active as it can react with vast number of hot acids and alkalis. For example, hydrochloric acid. You can watch this video to see how the reaction occurs. For reactivity with alkalis, aluminium can react with hot alkalis such as sodium hydroxide and lime water. In this slide, I use sodium hydroxide as an example. At the end of the reaction, you can see that the sodium aluminate and hydrogen gas will be produced. This reaction is highly exothermic once established and is accompanied by the rapid evolution of hydrogen gas. From my previous explanation, we can say that aluminium is amphoteric since it can react with both acids and alkalis. If you would like to know more about aluminium and its properties, make sure you watch this video. That's all from me. I will pass the next slide to Ayn to explain about purifying of aluminium oxide. Thank you.
Thank you, Rabi'atu Adawiyah, for the great explanation. Okay, for my part, I will explain about aluminium ore and also how aluminium oxide will produce. Okay, let's begin. First, what is aluminium ore? Aluminium ore is also known as bauxite. Aluminium is usually extracted out from the bauxite and also contains titanium and silicon oxide. For your information, for the semi-finished product of extracting the ores is alumina, which is aluminium oxide, and also the metallic aluminium is produced by electrolysis. Okay. I will explain about purifying of aluminium oxide or the process how to produce aluminium oxide. Okay, this process also known as Bayer process. What is Bayer process? Bayer process is the principal industrial means of refining bauxite to produce alumina, which is aluminium oxide. It will undergo three processes. The first one is reaction with sodium hydroxide solution. Second, precipitation of aluminium hydroxide. And the last one is formation of pure aluminium oxide. We proceed for the first process is reaction with sodium hydroxide solution. In this process, bauxite is crushed and it will treated with high concentration of sodium hydroxide solution. The concentration, pressure, and also temperature depends on the types of bauxite and how much aluminium oxide in it. Second one, aluminium oxide reacts to give sodium tetrahydroxoaluminate solution along with a hot concentration of sodium hydroxide solution. The other crust stay as solid. And for the other metal oxides, tend not to react with the sodium hydroxide solution and remains unaffected. But some of the silicon oxide reacts and form a sodium aluminate silicate which precipitate out. In this process, the temperature is about 140 degrees Celsius to 240 degrees Celsius, and the pressure can go high as 35 atm. Okay, the high pressure is essential to keep the water in sodium hydroxide solution as a liquid above its boiling point, which is 100 degrees Celsius. For the next process is precipitation of aluminium hydroxide. Okay. The sodium tetrahydroxoaluminate solution in this process is cooled and seeded with the some previously produced aluminium hydroxide. This could give something for fresh aluminium hydroxide to precipitate around. As can't you see in this equation, the sodium tetrahydroxoaluminates will undergo cooling process and the aluminate and the aluminium hydroxide in the sodium tetrahydroxoaluminate will precipitate around and produce the aluminium hydroxide. And for the last process is formation of pure aluminium oxide. The aluminium oxide from the precipitation process will undergo heating process is about 1100 degrees Celsius to 1200 degrees Celsius and produce the aluminium oxide and water. So this three step is important to produce the aluminium oxide. To make it more clear, this is a summary of Bayer process. As we can see, the bauxite will crush and will react to the sodium hydroxide solution and produce the sodium tetrahydroxoaluminate. The sodium tetrahydroxoaluminates will undergo cooling process in the precipitation of aluminium hydroxides and produce the aluminium hydroxide. The aluminium hydroxide will undergo the heating process in the rotary kiln and produce the aluminium oxide. That's how aluminium oxide will produce. That's all from me. We proceed to Emilia for the next subtopic. Thank you.
Thank you, Ayin. Okay, let's continue with the next part, which is conversion of aluminum oxide into aluminium by electrolysis. In electrolysis, the ions must be free to pass through the electrolyte, so it has to be in either molten or aqueous solution. However, the aluminum oxide extracted by the Bayer process is in solid form, so we have to melt it to turn it into a molten form. However, the aluminum oxide has a very high melting point, which is around 2050 Celsius. This requires a very high electricity. So, to reduce the melting point, a molten kerolite, which is another aluminum ore that is rare and expensive, is dissolved into the aluminum oxide. As a result, less energy is required to operate the electrolysis, hence less expense is needed. So, in this diagram, the carbon anode and carbon cathode are made up of graphite, which is a very good conductor of electricity. Okay, so as we know, opposite charge will be attracted at the anodes and cathode respectively. So at the anode, oxide ions will release its electrons and produce oxygen gas. So here is the half equation, which is oxide ions will release 4 electrons and form oxygen gas. So the electron released by the oxide ions will eventually sit at the cathode. So at the cathode, the aluminum ions will gain the electron released by the oxide ions and form aluminium. So here is the half equation. Aluminium ion will gain 3 electrons and produce aluminium. So the pure molten aluminium will sink at the bottom of the tank. This is because the aluminium is more dense than the mixture of aluminum oxide and molten kerolite. From time to time, the aluminium will be siphoned out of the cell while the aluminum oxide is added at the top. Next, there are a few operating conditions for the electrolysis of aluminum oxide. The first one it requires a very low voltage, which is around 5 to 6 volts. And the second one it requires a very big current, which is 100,000 amperes or more. So the highly current will correlate to a very high temperature around 1000 Celsius. So the cell here it will become very hot, and as a result, the oxygen gas form will react with the carbon anodes here. So eventually the carbon anodes will burn away and eventually wear out. Carbon anodes is no longer functional. Therefore, the carbon anodes must be replaced regularly. So this is one of the main reasons why electrolysis of aluminum oxide is uh, is expensive, and because it has to replace the carbon anodes regularly, and also it needs a molten kerolite, which is another expensive aluminum ore. That's all from me. Let's continue with the next presenter.
Alright, so next we move to the uses of aluminium. Normally, aluminium is alloyed with other elements such as copper, magnesium, and also silver. Okay, why is aluminium alloyed with other elements? Because originally aluminium is not strong, but by alloying it with other elements, it can improve the strength of aluminium. Okay, aluminium is useful due to first, its low density. Second, its good electrical conductivity. Third, because of its good appearance. Fourth, because of its good corrosion resistance. And fifth, because it is strong when allied with other elements. Next, we move on to the application of aluminium. First of all, in power lines. Okay, aluminium is ideal for wiring power grids, including overhead power transmission lines and local power distribution lines, because aluminium is light, it is corrosion resistant, it is a good corrosion resistant, and it is a good conductor of electricity. So it can flow electric well. And about the corrosion resistance, we know that when it rains and or when the wire is wet, so the wire will not be easily corroded. Next, instead of power lines, we have frying pan. Why is aluminum used to make frying pan? Because it is a great conductor of heat. So it can flow heat well, and it can make the food to cook more faster. Why is aluminum an ideal choice for cookware? Because first, it is light. Aluminum is light. It has good corrosion resistance, and also it is a good conductor of heat. Okay, next is transportation. Transportation such as high-speed trains, ships, and also aircraft, and also cars. Okay, why is aluminium used to build this transportation? Because it is light, it has a good corrosion resistance, and also it is strong. Okay, because of the strong aluminium, it makes cars safer. It makes the transportation safer, as it has the ability to absorb kinetic energy, which means that it is able to reduce the impact of collision. Okay, for aircraft is built with aluminium because of it is safer. It has a good corrosion resistance, as we know, and the good corrosion resistance is much more safer for the passengers and for the aircraft itself. Okay, aluminum is also an essential element in the construction of high-speed trains, subway cars, ships, and also rockets because of the same factor. It is light, it has good corrosion resistance, and it is strong. That is all from our group. Thank you.